Hello, my name is Kyle Kelly, and I'm going to show you how to use the bridge control panel to test I2C peripherals connected to your PSoC chip. Okay, so let's say you have your PSoC, your BLE chip, and your motor driver chip all on the I2C bus. And you're programming your PSoC and you're wondering if maybe there's something wrong in your code, or maybe there's something wrong with your wiring or your peripherals, such as the BLE chip or the motor driver chip. So it's sort of, let's see if these devices are communicating on the bus, and then we'll know whether or not our code isn't working, or if the peripheral is what the problem is. So I've built a quick example program that is for the BLE chip on the 149 kit. We're not going to use the Bluetooth component, so I'll disable it. We're going to use the I2C. We're going to set it as a peripheral on the I2C bus. And to do that, the easiest way I've found is to set it to easy I2C and just naming it I2C. The rest of it, the defaults are fine. You'll see in the second tab that the default address is hexadecimal 08. Actually, I want to back up for a second. The 7-bit address is hexadecimal 08. So there is also an 8-bit address, which is just another digit on the right, so the least significant digit. So 0x08 looks like that in binary. And then 0x, well, if you added a digit, I guess, like this, like another 0, then that is actually 0x10 in hexadecimal. And that last digit, whether it's a 0 or a 1, that tells the device whether or not we are reading or writing data. And we can make use of that using the bridge control panel. Okay, one more thing. When you change that last digit to a 1 in binary, the hexadecimal obviously would also change. It becomes hexadecimal 0x11. Okay, back to my example here. So what I've got a motor driver wired up to my I2C bus and the BLE device hooked up to the I2C bus. And I'm going to test both of these using the bridge control panel. So the setup for the BLE chip to make that happen is pretty simple. Obviously, I went over the easy I2C block setting, and then in the main file, you'll have to start the I2C block. You'll have to set up a buffer. So I set up a 4-byte buffer. I just said, A, 2, B, and 15. And these are like 2 and 15 are in decimal, and then these are characters. So when we read it, it'll come up as some number like 60 something in hexadecimal, but it's not a big deal. And then you tell the I2C block that that's our buffer. We tell it we have 4 bytes and we can read and write all 4 of them from somewhere else, and this is the buffer right here. Let's enable interrupts, and then in the for loop, you don't have to have anything. It's all automatic. And I already programmed it like this, but I mean, I'll do it one more time. So I'll hit this chip button. Oh, okay. So I already connected. This is something you'll find is if you're connected to the I2C bus using the bridge control panel, you have to click this disconnect block to reprogram your chip because it's using those pins. Okay, I want to be clear which pins I'm connecting to. So I'm going to show you. So you can use different pins for I2C, different I2C buses, but only one set of them goes through the kit prog into the USB port for testing like this, or just full-time usage. Okay, where it's not load then. There we go. So you'll see for the PSoC for this kit, pins 3.0 and 3.1 are on the I2C, and then it splits it out, and that's because it goes to the bus for the kit prog, and then this bottom one BLE, it connects to the BLE. So that's how you know whether or not you're using the right pins. Check out the schematic. Okay, finally, let's go towards the bridge control panel. So this is a separate program. If you just hit the start button and then start typing bridge control panel, you know, there it is, right there. It's usually downloaded with the PSoC creator application. So let's read, well, let me open up the thing. So I've got A to B15. So you should be able to recognize at least two of those. So let's read from the 7-bit address 08. Let's read all 4 bytes. This is a read start condition, and the P is the stop condition. That's what those mean. And the X's represent bytes. Oh, okay, let's back up a little bit. I probably could have clicked kit prog down here to connect, and it'll say whether or not it's connected down here. And then once you do that, you can click on a line and press enter. So it doesn't run every line in here. It's just the one that your cursor is at. So when I click on that first one and I press enter, I get plus signs, which is good. So plus next to 08 means it did find and communicate to that chip, and then plus signs means it successfully grabbed these bytes. So there's 6102, 62, and F. So F is 15, F is in hexadecimal, and then there's 2 is 2, and then 61 and 62 are the hexadecimal representations of A and B. So the read worked. You can also do it using a standard start condition, but then you have to use the full 8-bit address and declare the correct read-write bit at the end of it, like I talked about earlier. Oh, where's my notes? So it's either gonna, so when you add the byte or the bit to that set, so here's 08, and then if we added a bit to that, a 0, let's look way down here. So then there it is right there. So that's 10, and then 11 has the 1. So one of those will be read and one of those will be write. Thankfully, the bridge control panel recognizes the last bit when you have an S command. So if I try to put the wrong one, the characters turn red after, and that just means these X's are obviously for a read command, but a 0 means write, so it's not going to work. So if I press enter on this one, I should get the same values, and there it is down here in the bottom, the same values right there. So let's move on to this next part. How do we write to a peripheral? So let's write to the BLE chip. So let's use the write command. And to be clear, this R and the W, that just sets the final bit. And the same thing is true when you're programming in here. So there's a way to read and write data when you're acting as the master. You can do it line by line, and you might have to use the full address, declaring that last bit. Where when you do like the one command that's something like master read buff, that read, so it knows. So that means that you'll be using the 7-bit address. So that read function, it'll set the last bit for you. Anyways, So write to the BLE chip. Let's write to 08. And then the bridge control panel has this bit shifting thing that goes after that. You're going to want to just set it at 0. And you'll be able to write to the following bits in order. So I'll write to all 4 of those, 1, 2, 3, 4. So there it is down there. The plus means it was successful. So let's do one that wouldn't be successful. So let's change this to 6. So then see those minus signs. That means it didn't work. Anyways, so earlier we wrote 1, 2, 3, 4. So let's just click up here and press enter, and I should be able to read 1, 2, 3, 4. Good. And then you can do it with the S command, and you would declare it as the 8-bit address with the last bit being 0 for a write. And I'll press enter, and I write 5, 6, 7, 8. And let's do a read with the S command this time. And also successful. We read 5, 6, 7, 8. Okay. So now I have a motor driver chip, and I'll be able to share my yard sale webcam. Okay, so you should be able to see this tiny little motor I have connected to the bus, well, to the driver I have. And I happen to know the address is 60 in 7-bit. So, and I think A0 should spin the motor. Okay, let's find out why A0 didn't run the motor. So looking at the data sheet for my motor driver chip, it is a rather simple I2C motor driver. And if I search for register map, I'll see that there are 2 registers, the first being for control and the second being for faults. So the control register talks about it right here. The 2 least significant bits are these IN1 and 2. That's for setting the state of the outputs, or the direction rather. So if you powered both of them, it would hold the motor still, like with power. And if you set both of them to 0, it should de-energize both coils, or both sides of the coil, and then let you spin it by hand. And if you set either one of them to 1 and the other to 0, it should set a direction. And then the other 6 bits are for setting the speed. So let's say we chose a speed of 0, 1, 0, 1, 0, 1 for my 6-bit speed. Or yeah, that'll be decimal 21. And then 6 bits, that only gives you a resolution of 64, so this will be just under half power. And then for the final 2 bits, I will choose a direction of 0, 1. I don't know if that's clockwise or counterclockwise. Let's see, how do you tell it to go? Enter isn't working. Okay, let's just bring that up here. $55. Okay, so we'll send 55 to the motor driver. 55. Let me share the yard sale webcam again. And click on that line and press enter. Okay, as you can see, the motor's spinning. Little piece of tape turning. And my cat is attacking me. Okay, and then I'm going to write 0 to slow that motor down. Actually, let's find out how to read to this device. So it's actually a little bit more tricky. So we'll write that so it's spinning. And then you'd think if we put read right here and then 60 for the address and then ask for the first register, which you'd think would be the register we just wrote to, it actually gives us some weird numbers. So it gives us a 4 and then a 0. I don't know what it's talking about here. So something's not right there. So if you look back at the data sheet for this, right here, it talks about read mode, like how to read these addresses. So you need a start condition, the address of the chip, the address of the register, and then another start condition, and the address of the chip again. So we can do that, we can accomplish that using, let's do it with let's do it with S commands. Doesn't work. Oops. Okay, and to add a line in here, you right click and then insert row. If you press enter, it doesn't add a line, it just runs it, right? So S, oh, and then adding a digit, let's figure out what the address should be. Oh my god, okay, here we go. Can we swap this around? I don't know. Oh, swap hex to binary. So for the hex value of our, what was it, 60? Our motor driver, I got that from the data sheet earlier, is this. 1, 2, 3, 4, 5, 6, 7, 8. So it actually added a 0 on the end of this. That's why it's a little confusing. It's not actually using that 0. So when we add the bit to the right, whoops, let's just copy this and go back. Here we go. So we added the bit, and now it's C0, and then the read write C1. So C0 and C1. Let's go back to the bridge control. So S is start, and then C, what do we decide the last bit should be for reading? A1. Okay, start, and then the address of the register, was it? Let's go back and check that real quick. Yep, and then start, and then address again. Start, and then C1 again. Oh, actually, should be a read command. Oh, I see. We're not writing. We're asking to read. And then we write. Oh, shoot. We read. There it is. Confusing. Well, it's not mad anymore, so let's just try it. Oh, okay, it worked. We got our 55 out of it. So, if when you're reading it doesn't work, you might try doing it manually instead of using the pre-built read functions. And the same goes in the code. There is a way to go about reading data using individual commands such as like start and then read, and then instead of just the read buff, like all in one kind of deal. Okay, let's stop this motor from spinning. And the last thing I want to show you is how to chart data in here. So let's say you, I don't know, had data that was changing and you wanted to see it change in real time. You can do that. So we'll read from our BLE chip, which was 08, and then these keys, these @ keys, they're defined in the variable settings. So there's a button here. It's also in the chart drop down. And you can change the names. I'll just leave them though. And I activated the first 4 because I have 4 bits. I mean, I'm only going to change one of them. And then there's some other settings in here. I just left them all at defaults. I just checked them. So now that they're set, the chart should be able to chart them. It'll know to send the data I'm pulling to these variables. And then if you run it once, obviously that's not going to be that great. But if we click on the line and then hit repeat, it'll keep reading it. But as you remember, my code doesn't have our values changing yet. So I'm going to uncomment out these 3 lines I have. It says if our second byte is greater than 200, then set it back to 0. Otherwise, add 1 every 10 milliseconds. So I'm going to program it. Oh, and as you know, it's not going to work. Bridge control, disconnect, go back. There it is. Let's go. Okay, so now it should be going up to 100 and then back down to 0. So I'll click here, and then I'll click, oh, not connected. So down here it says kit prog. If this doesn't work, you might want to go to programmer. I just realized if this isn't showing up for you, PSoC programmer, and then go to utilities and click firmware upgrade. Okay, so clicking on it, it's connected. Now I'll hit repeat on this line, and you see there's something going on here, and then in the chart, there it is. It's counting up and then just going right back down to 0. So there you go. I hope that helps. If you have any questions, hit me up on Slack, and see you in the next video.